Thank you, everyone, to be with us today. I'm very pleased to welcome you, to welcome our speakers, and to welcome my colleagues from bioMérieux. I am Sébastien Manuel. I am the Regional Business Manager for the Quality Indicator Solution at bioMérieux in the EMEA region, meaning Europe, Africa, and Middle East. Today, we are going to speak about, I would say, a new microorganism, new spoilers that people are talking more and more about it. So the topic will be about Alicyclobacillus. We will have two speakers. I have with me to animate this webinar my colleague Frank Andrieux, which is from the Global Marketing Food of bioMérieux. And I would like from the beginning to thank you, two other colleagues that I have who help us to prepare this webinar. Stéphanie Salin from the EMEA Food Marketing, and my colleague Sébastien Chalat, who is from the Global Food Communication. So the webinar will be split in three parts. First part will be with Dr. Emilia Rico from the company BCN Research Laboratories, which is based in the United States. And she will give us a very nice presentation, a general overview about Alicyclobacillus, detailing about the risk and the impact of having Alicyclobacillus in the beverages industry. So will be our first speaker today. Then is going to join us one of our colleagues from bioMérieux. His name is Benjamin Pascal. He is also based in US, in Philadelphia. And Benjamin is going to give us an overview of new solution developed by bioMérieux for the detection of Alicyclobacillus producers of Guaiacol within a day. And the name of this solution is GeneUP Pro ACB. So please, we keep your question. If you can address your question in the chat room during the presentation of the two speakers. And we will dedicate around 10 minutes at the end of the session for a Q&A session. So please, you can write your question in the Q&A session, which is available in the GoToWebinar system. And let's go for the first presentation with Emilia Rico. So, Stéphanie, if you want to give the ball to Emilia, and I will introduce Emilia to the audience. Alors. So, Emilia, thank you for being with us today. You are an early bird today. I think it's around 7:30, 8 o'clock now, where you are located in US. So thank you again for being with us so early. So Dr. Emilia Rico is a native from Spain, and she received her master's and PhD in food technology and science with emphasis in food microbiology from the University of Tennessee. And she has been trained in food microbiology mycology by world-leading food microbiologists such as Dr. John Pitt, Dr. Aliza Hawking, and Dr. Rob Sanson. In 1988, she founded the BCN Research Laboratories that is currently in Rockford in Tennessee. BCN Lab is an independent testing laboratory specialized in food microbiology, mycology, and food safety. In 1994, she co-founded Universal Sanitizers and Supplies, Inc., a food sanitation service company, which is dedicated to the reduction and the elimination of fungi, yeast and mold, from the processing environment. Emilia has done very extensive work in food mycology, microbiology and mycology, including working on HRM, so heat-resistant molds, xerophilic fungi, preservative-resistant fungi, Alicyclobacillus, Guaiacol positive, that we all name ACB, and other kind of spoilers. She is very well known for her expertise. I got already the feedback of some people 2 weeks ago in DrinkTech telling me, oh, you know, Emilia, she's an expert in spoilage investigation and for the prevention of beverages on high acid foods. Since 2003, Emilia has been an active member of some international organizations like the ICFM, which is the International Commission of Food Mycology, of the International Union of Microbiological Societies. She participated to many committees, many symposia, many workshops, and she has dedicated most of her career to the promotion of food mycology. She has trained numerous food and beverages companies personnel in food and beverage microbiology and mycology from the US and in Latin America and in Europe. She has been the co-author of 2 chapters in the 5th edition of the Compendium of Method for the Microbial Examination of Food. She is really an expert, and I really welcome her for this presentation. So the floor is yours, Emilia. You have around 30-35 minutes. So thank you again for being part of this webinar.
All right. So thank you very much, Sebastian, for the long presentation, introduction. And thank you for inviting me to speak about the second subject that I really love. A lot of the people know me because of the HRM and other mold spoilage issues, but certainly we have been working with Alicyclobacillus for the last 20 years. And we started when one of our customers had a problem in a sport drink. At the time, it was more juice spoilage, but certainly sport drinks can have a problem too. And they wanted us to test liquid sugars, liquid sweeteners. So I contacted Dr. Kathy Jensen in Australia, and she was really helpful. At the time, we did not have as good methods as we have now. So let's start and let's talk about Alicyclobacillus. So with thermal processed beverages and juices, you can have a spoilage by bacteria. Some people think because of the low pH, they cannot spoil, but certainly there are some groups of bacteria that can cause spoilage. The first one is the heat-resistant bacteria, and we have Alicyclobacillus and Spodolactobacillus, which is a lactic acid bacteria that can produce spores. The second one are the heat-sensitive bacteria, and there you have your lactic acid bacteria and acetic acid bacteria. So in this webinar, we are going to talk mainly about Alicyclobacillus or TAB. So I have used a lot of references, but I certainly have used the Alicyclobacillus best practice guideline from the European Fruit Juice Association. I think it is very helpful. You have to realize that the taxonomy and the methodology is a little bit outdated because this came in 2008. So I want to make a little bit emphasis on what thermophilic, acidophilic, spore-forming bacteria are and Alicyclobacillus. So these bacteria are usually gram-positive, non-pathogenic, thermophilic, which means that they like to grow at a high temperature. They are acidophilic, which means that they also like to grow in a lower pH. And they can grow between 0.7 and 3, the pH, and temperatures of above 50. Now, this is the definition of TAB. However, Alicyclobacillus are also known as TABs, but they are more moderate thermophilic bacteria, and they are acidophilic, and they are also called ACBs. I think ACB is more of a direct term that means Alicyclobacillus, while TAB, you may have some other things, even though a lot of them are not seen in foods. So the Alicyclobacilli were first isolated from soil in thermophilic environments. They are also from gardens and forests and some other non-thermal environments. Now, as I said, they were first isolated from soil in orange groves in Brazil, on the surface of the leaves of the oranges. So therefore, these are soil microorganisms. And it is amazing how close these are from the heat-resistant molds because they follow very much the same way of spoilage. Heat-resistant molds are also soil microorganisms, and all these spores get enriched, and they enrich the soil in the orchards, groves, in all these places where fruits and other things like cane and beets and things like that are grown. So the first spoilage was in 1982, and it was in a juice that was not cooled fast enough. This happened in Germany. It was a hot summer, and it was the bottles were left to cool naturally. And then what they found out is that the bottles had a flat, sour spoilage that generated a medicinal smell. And therefore, this was the first time that they noticed that there was something in the juice that produced this. The juice did not change in characteristics, but certainly the smell and the flavor did. It can be isolated too from water, from the activated charcoal filters, from the condensate water. So the washing water of the fruit. All this makes us believe that water may be the second source of spoilage of these spores. So the Alicyclobacillus refers to this alicyclic fatty acids in the membrane that give them very high heat and acid resistance. Now, not all of the species have them. They also have hopanoids or hopain glycolipids, similar to cholesterol, and also make the membrane more rigid. So this is an advantage at low pH. Currently, we have at least 28 species and counting. Every time I do a search for the species, there are new species that are coming out. However, we have to say that still Alicyclobacillus acidoterrestris is the predominant spoilage strain. Now, there are some others that have caused spoilage of juices, like Alicyclobacillus acidiphilus, Herbarius, Pomorum, Hesperidium, Cycloheptanicum, contaminants, Dausi, and Dusi. But certainly they are encountered in more rare occasions, but they can still be relevant to the spoilage. So Alicyclobacillus can metabolize sugars, but they produce maybe a little bit of acid, but they do not produce gas. They do not produce any cloudiness in the juice. So the main symptoms that you have a spoilage is because of the smell, medicinal, phenolic, sanitizer smell, and also the taste of the product. Now for the growth, they require a water activity of more than 0.9. So even though some species have been reported to grow at 18 bricks, usually they require a lower bricks concentration and a higher water activity. The optimum water activity is 0.992, and they certainly retain viability in fruit concentrates and things like that in liquid sweeteners. But you have to remember that if you're going to do an enrichment, you have to dilute these samples to a water activity of 18 or less if possible. Otherwise, they will not grow in the enrichment. Now, they are acidophiles, and they can grow at a low pH, usually from 2 to 6, but the optimum is 3.4 to 5.5, which are usually the pHs of juices and beverages. And the temperature, they range from 20 to 70, with an optimum between 40 and 60. Now, some species can grow to very low pHs of 1.5, but usually these species have not been encountered spoiling juices. They are strict aerobes, even though, as with the heat-resistant molds, they can grow at 0.1% dissolved oxygen. So just by having this little oxygen dissolved in the beverage, they can grow. There has been reports of one strain that grew anaerobically, and certainly Alicyclobacillus polye can also grow anaerobically, but this one is also not being found spoiling foods. So of the juices, certainly the most common are orange, pear, apple, peach, tropical nectar, white grape, and grapefruit, but certainly it grows slowly in the grapefruit. Now, the presence of passion fruit may be a stimulatory, so when you are mixing juices in your formulation, you have to take this into account, that some of the juices are going to be stimulatory, some of them will be inhibitory. it can certainly grow in a diet orange or multivitamin fruit juices, and they can spoil sport drinks, shelf-stable herbal teas and teas, vitamin-enhanced water, flavored water. So this is not just a problem of the juice industry. It cannot grow at a high ethanol concentration, so wine may not be spoiled by it, but cider certainly can. And then the spoilage usually happens at a higher temperature or a slow cooling down of the product, even though some strains can grow at room temperature. So that's something that you have to think about. Now, I really believe that the risk of the spoilage will vary according to the product type and the presence of precursors of the taint. So the formulation is very important. If you have the precursors, then your spoilage is going to be more noticeable and it will be faster. If you don't have any of the precursors, you may not have a spoilage, even though you may have presence of Alicyclobacillus spores. Now, they are quite heat resistant. They devalues the reduction of a population by 90%. And certainly, as you can see in the slide, the devalues at 90 degrees centigrade, 95, even 100 are not enough. I mean, they are quite resistant. So the pasteurization of juices and beverages that we use nowadays will certainly don't prevent the spoilage. If the number of spores is high enough, if the spores are resistant enough, you will have a spoilage. Now, the heat resistance actually is higher in juices, concentrates, and beverages than in buffers. So knowing the heat resistant in your formulation is very important. Do not rely only on the numbers that are published on buffers. So this is really important, and I really believe that it's very unrealistic to guarantee that any product will be absolutely free of Alicyclobacillus. And that doesn't mean that every product is going to be spoiled. As I'm going to explain a little bit later, you can have presence, but it doesn't mean that you will have a spoilage. So in this type of spoilage, you have these off flavors and others that are formed. Certainly the most predominant is Guaiacol, and the others are halophenols. For the Guaiacol, you have some precursors. It is believed that ferulic acid and tyrosine may be the precursors for vanillin and vanillic acid, but some of the formulations already have vanillin. Then the halophenols, you have the bromophenols and the dichlorophonols. Now, as I say, Guaiacol is the most predominant and usually is quite noticeable when the concentration gets to 10 to the 4th, but even 10 to the 3rd, I mean, it will take a longer time, but you will see it. If you have 10 to the 5th, for example, the production of Guaiacol will be quite fast. So all these are the precursors, and then we don't know exactly what the precursors are for the halophenols, but you have to take into consideration that the spoilage may happen with a mixture of these products. So I'm going to talk about the most common Alicyclobacillus species, and certainly Alicyclobacillus acidoterrestris is the most common, the one that is producing most of the spoilage in many cases. And it does produce a Guaiacol and some DBPs. It can grow down to 35, and certainly the pH is very much to what the fruit juices and beverages are. Then we have Acidocaldereus. Usually it likes higher temperatures. It has been isolated from some tomato products and even some fruit juices, but it does not produce the typical of others and of flavors than the others do. But still it can produce some type of flavor. There are also 2 subspecies now. Then contaminants has been isolated from spoiled juices. Herbarius has its name because it was isolated from an herbal tea. The hibiscus flowers had it. It has also been isolated from kiwi juice and pomorum. So all these have been isolated with some type of spoilage. Then we have Hyglochelpsanicum. It's quite, it likes also to grow on higher temperature. Hesperidium usually has been isolated from soil, but did not give it time. You never know. It may be in fruits and fruit juices. Then fastidiosus, the thing about fastidiosus from apple juice and acidiphilus and dowsy is that they can grow down to 20 degrees centigrade. So that means that if you have this and you do not cool your product fast enough below 20, you are going to have a spoilage. Now, from the liquid sugars, is Alicyclobacillus saccharide, and to the moment, it has not been reported to produce Guaiacol. And certainly we have the famous Alicyclobacillus susi, which is very, very, very closely related to Aspergillus acidoterrestris. It produces Guaiacol. It grows in similar temperatures and pHs. Genetically, it is quite close. And then you have Mali and Fructus that have also been isolated from fruit juices, but they have not been reported to produce Guaiacol. So what are the sources of contamination? You certainly have the packaging, even though I have not seen any studies on this. We have a lot of information on heat-resistant mold ascospores in packaging, but Alicyclobacillus is something that has not been done yet, or I haven't seen. You have the equipment, the processed water, the ingredients are the main source of spoilage. So you have your juice concentrates, purees, liquid sweeteners, granulated sweeteners, tea and herbal tea leaves, flavorings, anything that has vanillin or vanillic acid, even if it's just a flavoring, will be a precursor. Then the processed water, you have to be very careful with the evaporator condensate and the activated charcoal filters and anything in the process of the system of the processed water. The problem with the equipment is that the Alicyclobacillus is a big biofilm producer. So it is very easy for it to grow and produce biofilm. And the higher the temperature, the better for biofilm production. That's why the evaporator, the condensator may have problems with this biofilm. And as I said, the packaging is something that we really have to study. Now, the prevention of ACB contamination needs controls at every stage of production. So many people will say, well, I'm gonna control anything on in the finished product production. But in actuality, in this case, harvesting and the semi-finished product production are very, very important. For the harvesting, certainly you have to have a quality of the raw materials, the fruits, how many fruits are taken from the soil, fallen fruits, how many fruits are damaged. All this will have an effect. You have to avoid soil contamination because remember, this is a soil problem. The washing of the fruit, it has been shown that things like acidified sodium chloride, which gives a mixture of chlorous products, including chlorine dioxide, aqueous and gaseous chlorine dioxide work very well. The problem is that in Europe, you may not have access to these products, but in the US, they are readily available. And certainly the washing is very important. And the second thing is the semi-finished product, the concentrates, the purees, the things like that. You have to be careful in the manufacturing, the water, the condensate water. Do not reuse the condensate water or the evaporator water. And then again, storage, transportation, and sanitation. The sanitation is very important. And again, the products that have worked the best, even though, there are mixed, the literature is a little bit mixed about sanitizers, but acidified sodium chloride and aqueous chlorine dioxide. The finished products, the same. You have to be very careful about the processing, the filling temperature. Remember the filling temperature. If these spores are inside of the bottle, it will activate them. The sanitation, the same thing. These are the best sanitizers. And then during the storage and distribution, if the product has been contaminated, then you have to avoid high temperatures during both. So, okay, now you have it in the product. What can you do processing-wise to get rid of the spores? Well, in actuality, pasteurization will not get rid of them. In fact, you are activating the spores for them to grow later on. So the pasteurization step is helping the spores to grow. Then you have high pressure processing, but by itself is not as effective, again, because you are activating the spores. If you don't kill them, you activate them. And then you have the pasteurization with a higher temperature, which is a little bit more effective, but it depends also on the formulation, on the soluble solids and things like that. Then you have other things that are non-thermal, like thermosonication, but it also requires higher temperatures and a longer time. Then you have UVC, which is promising. However, it has low penetration and it needs a longer time. A lot of these things are more like a batch processing, so they may require a longer time. And then the last one is the homogenation at high pressure. Again, it is not effective by itself. So, okay, let's say that all this processing, they did not kill the ascospores. Now you can inhibit them in the product so they do not grow. So you have preservatives. They are very effective, but consumers do not want preservatives. There are essential oils that have been shown to be effective, but again, they can have an effect on the taste of the product, and certainly they can make the formulation a lot more expensive. Then plant extracts and juices, but I think we still need more information. And certainly nicing and the nicing in biofilm, in films and packaging is effective. The only problem with nicing, it inhibits the gut microbiome, and there may be some problems with people ingesting a lot of products with nicing. Okay, so you need multiple hurdles to prevent the spoilage. So you may have pasteurization and preservatives. You can have high pressure and preservatives, high temperature, pasteurization and nicing. I mean, you name it. You can do several of these things, measures that I talk about to prevent it. So the recommendations are that you follow the Alicyclobacillus best practice guidelines or something similar. They really outline a lot of these problems and how to prevent them if possible. You have to establish a testing regime for the water used in the plant. Some people are using the evaporator, condensate, and things like that. They are reusing them. Some of them are cleaning with some of these waters, and that is not a good practice. Monitor the raw ingredients, including packaging, and using the right methodology. And certainly you have to establish specs. And I know some people are doing like 1 meal or 1 gram or 10 meals, 10 gram. For that may be okay for the finished product. For ingredients, I really believe that the specs should be per 50 or 100 meals or grams. Then carry out the supplier and raw material carry out risk assessments, because you need to know how your suppliers are handling the products. Then cool the product to less than 20 as fast as possible, but sometimes this is quite a challenge. Implement a strong sanitation program, and you certainly have to use a spodocidal product. In the US, is any of the chlorine dioxides, but you really have to think about that. Prevent biofilm formation because of the same. Alicyclobacillus will produce a lot of biofilm, and you have to remove it even if it's not seen. I would do this periodically. Use the right sanitizer again and the right concentration. Remember that there is a concentration for food contacts and another for environmental. So the research needs, I mean, we have a lot of controls and preventions in place, but still what we need is to monitor the ingredients, the processed water, processing environment, as well as validate and verify your sanitation procedures. The early detection using a rapid and reliable method is necessary. And the early detection in the finished product is really a requirement for the food industry. The research should focus on making the actual methods better and in getting new methods that will ensure the rapid detection of Alicyclobacillus to preserve the quality of fruit juices. And actually, this is what Ben, the following speaker, is going to be talking about. So this is all. Thank you very much, and I will answer the questions later.
We cannot hear you, Sebastian.
Sorry, I was saying thank you, Emilia, for this nice presentation, giving a lot of information regarding Alicyclobacillus on the risk on the way to prevent also Alicyclobacillus during the process, during manufacturing, and also how is it important to test for the raw materials also during harvesting. We have a lot of questions for you, so we will do it after Benjamin presentation. So just to introduce Benjamin, Benjamin is a thought leader in innovation and rapid diagnostics. He's from Philadelphia. He's a proud guy from Philadelphia. Ben brings 2 decades of dynamic experience in entrepreneurship to his role at global diagnostic leaders at bioMérieux. He's serving as the global head of the company's X-Pro program. Ben will explain more about this program. He guides X-Pro initiative both domestically and abroad. And in his role, Pascal responsibilities include oversight of molecular research opportunities, development of new industry partnership, management of commercial X-Pro product launches, training of global team members of new X-Pro innovation, assessment of new technologies, and development of tactical marketing plans. A key initiative of bioMérieux, as said, is the X-Pro program, which allows the company to respond rapidly to emerging market segments, creating a cutting-edge molecular assays that address unmet microbiology needs for life sciences. And prior to his time with bioMérieux, Pascal co-founded Invisible Sentinel in 2006. He is known as the leading-edge molecular diagnostic developer and manufacturer. And he served in the role of CBO from Invisible Sentinels in 2019 when Invisible Sentinel has been acquired by bioMérieux. So Ben is going to give a presentation about a new, totally new, I would say, cutting-edge solution for ACB. So Ben, the floor is yours.
Great. Thank you so much, Sebastian and Emilia. As always, it was very informative. I'm always picking up a few things during our discussions that we have, whether at a conference or on a webinar like this. So we certainly appreciate it, Emilia. As Sebastian said, I am the global head of X-Pro, and we're very much the center of innovation with regards to molecular diagnostics for bioMérieux. And an area that, for me personally, in being in assay development for many years, that we're very passionate about at bioMérieux is with regards to spoilage, right? So, and I say that because it's an area that we know affects all of our clients on a daily basis, but it's an area for me that can be create a lot of questions and can be less understood than, let's say, if we have contamination with E. coli 0157H7, for instance, we know what to do, we know how to detect it, we know we're going to discard that lot. But with something like Alicyclobacillus, as we're talking about today, well, we have ACB, but are we going to scrap that lot or not? What are our actions that we're going to take? And as I say, and I think my colleagues sometimes get sick of me hearing it, not all spoilage is created equal. And I think the most important part for us when we're building assays is how can we understand these specific spoilage organisms better so that we can build a more predictive assay, not just tell you you've got Alicyclobacillus, but to tell our end client, is that Alicyclobacillus going to go on and produce the metabolites that could impact the overall quality of the product? And that's where the challenges come in, and importantly, that's where the fun comes in, I will say, in developing these types of value-add assays. So before I go further, one of the things that I talk about with my colleagues a lot, and why spoilage is so important to us as well, is I want to start out kind of higher level and say, if you look at the United States and you look at, importantly, globally, what's happening with the way population's expanding and the environmental pressures that we see on the food supply, 30 to 40% of the food supply is not consumed. And that's for a variety of reasons. And one of those main reasons is spoilage of the product, right? Shelf life of the product. And as we continue to see more environmental pressures, and I think it's important we point this out, we've seen the heat waves across the world over the past 2-3 years. We have a hurricane obviously passing through Florida right now. And as we see more of these environmental pressures, we're going to continue to put additional pressure on the food supply. And so one of the things that can help alleviate it, I say, are better diagnostics to help us, one, ensure shelf life, improve the longevity of shelf life that's out there. So can we expand that shelf life? And importantly, for, let's say, our quality heads and the clients that we work with on a daily basis, how can we provide tools that are going to be predictive as to whether something's going to spoil or not, right? So by being able to provide these types of tools to ensure that shelf life and be more predictive, we feel we're doing our part to ensure that we take some of the stress off and the burden off of the global food supply that we see out there. So, you know, in talking about that, some of the things that we do here at our Philadelphia site and with our colleagues globally, and what I want to focus on is current methodologies. We always like to look at what are the gold standards out there. Can we first and foremost ensure that we can build assays that meet those gold standards, but how can we then take that to the next level to ensure that we are indeed building a more predictive assay and providing more value for our clientele? So let's just take a deep dive in Alicyclobacillus. You know, current methods fall short with regards to time. It takes a long time to culture, to whether you're looking at the vegetative state of the spores, to ensure that we get growth of those organisms. And then the big part is you still, even if you do get growth of those organisms, how do you know, right, whether it's going to produce Guaiacol and impact the overall quality of the product? So we're looking at, you know, the two main methods that we typically see in the marketplace and are really the gold standards across the world are the IFU methodology. This was just revised in 2019, and then the JFJ coming out of Japan. Those two methods do a great job in terms of recovery of Alicyclobacillus. In terms of recovery of Alicyclobacillus, and also ensuring across a wide variety of variables that recovery of the Alicyclobacillus. So multiple juices, raw materials, concentrates, sweetener solutions. Both of these methods do a remarkable job in terms of recovery of the bugs. When you look at IFU, you've got a qualitative method, and I think it's important to note these two methodologies. And you've got the quantitative method, or the enumeration method, we would typically say here. So there are two main areas that with IFU regarding the methodology that's chosen, one being enrichment based and another being obviously direct plating of the organisms, the qualitative versus the enumeration method. But even if you get, as I said, those colonies isolated on a plate and you're waiting those, let's say, 5 days to get a growth on a plate, right? And then after that, if you do see growth, right, which one of those colonies that are there do produce Guaiacol or not? So you've got to run a secondary test. That's typically a peroxidase test. We've listed a few here from Doller and Cosmo Bio that we see typically globally being utilized to determine Guaiacol production or not. But also you've got to be able to, if you've got a lawn of colonies, you have to, how do you know you pick the right colony? You might have a mixed culture. So these are the types of things we think about so that we can tease down, find that needle in the haystack and determine, what is truly a Guaiacol producer or not. When you look at other methods in the marketplace, there are colorimetric based assays. So here you get CO2 production that creates a pH change. And this is utilized obviously in terms of workflow. These methods are pretty easy and simple in terms of workflow, but the same thing, right? Still takes maybe not quite as long as typical culture-based methods to get results, but it still does take several days. And importantly, you've got a high false positive rate. And most importantly, same thing. Is it a Guaiacol producer or not? Is this going to impact my quality or not? So you still would have to go on and run one of the, as we say, one of the benchmark peroxidase tests, which are really the gold standard chemical methods utilized for Guaiacol detection, production or not. Less common, there are some ELISA-based methods. There are some methods with flow cytometry, microcolony counters. again, same thing. You still can't determine whether it's going to produce guaiacol or not. PCR assays, which is the area that we tend to focus on most, obviously, give us some advantages in the marketplace. One, we all know with molecular methods, speed. Typically, LOD is less, and or I shouldn't say limit of detection is less, but your sensitivity of the assay is higher, which equates to shorter time to results. Specificity. There's certainly a lot of real estate we can work with on a molecular assay to make a much more specific assay to ACB. But still, when you look at molecular methods that are on the marketplace, it's still not predictive of spoilage. So what we try to do here through a series of various techniques is to determine, one, can we identify those spoilage organisms? And from there, can we determine what genes may be predictive for spoilage? We do that through a process, and I think it helps to go through it here. If we have a spoilage event and we're unsure of what's creating that spoilage, we have the ability to do a deep dive metagenomic analysis to first, and this is not 16S, this is next generation sequencing, where we can have the ability to look at a sample that might have mixed cultures and quickly identify what those spoilage organisms are. In the case of Alicyclobacillus, for us, we have to assemble that library of strains. We already know what spoilage organism we're looking for. So for us, it's about building up a significant library of strains of ACB from all over the world. And this is really the process we go through for building a next generation assay. The next thing that we look at is assess and assigning the phenotype. In the case of Alicyclobacillus, this is a binary phenotype. Does it produce guaiacol or does it not produce guaiacol, right? So that makes things pretty easy. And the way we assess guaiacol production and that phenotype is obviously by culturing those organisms and then determining and benchmarking guaiacol production against the gold standard. And this would be one of the peroxidase assays that I've talked about already. So we always want to benchmark when we're assigning phenotype, we always want to benchmark it against a gold standard methodology that's been, tried and tested in the marketplace. So once we understand, okay, we have our library of strains, we understand which ones produce guaiacol, which ones don't produce guaiacol. The next part where we start getting into some of the fun is we've got to do whole genome sequencing on those that produce guaiacol and those that don't produce guaiacol, right? So we're building up a tremendous database through whole genome sequencing of these different species, or I should say strains of Alicyclobacillus. And there we use a lot of our private databases and our bioinformatics team, both here in the United States and in Europe, to one, understand what are the differences, right, between those that produce guaiacol and those that don't, right? And can we assign, is there a gene or genes, right, from our whole genome sequencing, from our bioinformatic assembly that we can then build an assay against, right? So once we've identified those genes, we then will target that genetic signature that's the difference between guaiacol production or not, right? And determine, is that the right target we've gone after by building the PCR assay and doing wet lab work, right? So at this point then, we are obviously vetting that target to say, when we see that set of genes, it goes on to produce guaiacol. When we don't see those set of genes, we don't see guaiacol production. So we're essentially trying to prove out the work that we've done through all of our whole genome sequencing, our assessment of phenotype, and our bioinformatics to determine, do we see and does this target that we found that's different between the two organisms, does it hold the test of time and hold in our laboratory work? If it does, we then move forward with a full assay development of the product. And that's where this process that I'm going through, this is how we built what we call our GeneUP Pro ACB assay. So GeneUP Pro ACB targets a very unique signature within Alicyclobacillus, and at this point we have seen 100% correlation that when we see this gene, the organism always goes on to produce guaiacol. When we don't see this gene, we do not see guaiacol production. We've built an assay that gives you 3 data points as well, which is important. You know, we still want to know, do we have Alicyclobacillus, right? We want to know from an overall quality standpoint, do we see the species or not? I think it's very important, and our end clients have indicated they still want to know we're seeing ACB or not. On our channel, so this is a 3-channel assay where you get 3 data points in one test. So the second thing then is, okay, we have ACB. Does it have the genes, obviously, that we've demonstrated are the precursors for Guaiacol production or not, right? So now I know, okay, I've got ACB. It has the ability, it will go on and produce Guaiacol, and we've determined that through all of our work, or it won't, right? So again, we're providing that predictive assay to determine what do I do when I know I have an ACB hit. Third channel is internal amplification control, again, to ensure that the polymerase is working, the assay is working, the matrix has not affected the overall assay at all. So we built this assay with those 3 targets in mind, and we validated it against IFU. This is a 24-hour method, so we built into this a method that mimics very much upfront IFU, where we're taking the IFU enumeration method. I want to point out that's an important point. We're taking 10 mils into 90 mils of BAT or YSG. Both have been validated on the system. We're enriching for 24 hours at 45 degrees Celsius, and then it takes about 3 hours to result. So, you know, you're looking all in about 27 hours that we can determine that presence absence with the same equivalency in detection, and you'll see here through some independent data, we do actually exceed the LOD associated with the IFU enumeration method, which is about 1 cell per mil. And we determine quickly within the 24 hours, do we have ACB? And 2, is that ACB going to produce Guaiacol? So essentially it's pencils down. We know what we have in 27 hours. We know it's going to impact our quality or not. We can release the product. It's ACB. It's not going to produce Guaiacol at all. So I think it's pretty exciting that the team was able to come up with this. We've had an opportunity now to share this with many clients globally. What I think is even cooler is that the genes that we've targeted continue to stand up to different species of ACB globally that we're seeing in terms of Guaiacol production or not. So let me talk a little bit more about the kit, and then I certainly want to get into the validation data that we're seeing coming out from some very good groups that we've partnered with from a research standpoint. We're running this assay on our GeneUP real-time cycler. So this is an instrument manufactured in Florence that we build many of our assays on. User-friendly system, and we have our test kits that are already pre-aliquoted reagent tubes. They contain any necessary buffers that you'll see as we go through the methodology, and any ancillary equipment. So it's a very much a pretty streamlined system. And again, we can run up to 96 tests at once, but each test gives us 3 data points. Gives us obviously ACB species, lets us know, do we have the Guaiacol production genes or not? And then importantly, always got to have an IAC built into the system to let you know that that matrix is not affecting the product. That's important. Again, that I'll say is because with juices, you know, some of them can be complex. Some of the nectars can be complex. Things like prune juice we've seen can be somewhat complex as well. So some of these matrices can be challenging. So it's important to know that we've got an IAC built into the assay. When we look at the methodology, we follow exactly how IFU starts their methodology off. 10 mils of solution into 90 mils of BAT, and then we're going to incubate for 24 hours at 45 degrees Celsius. So it's nice when we do the 10 to 90 mil dilution up front, right? We can pull off that, and then our groups can validate and move to the IFU methodology as well, being that it's the same standpoint. We incubate for 24 hours at 45 degrees Celsius. So again, as Emilia had touched on, the bug does like warmer conditions for growth. We then, if we've got ourselves a puree or a concentrate, we'll centrifuge the sample. So we'll take 50 mils and we'll centrifuge that at 500 G. So a nice slow spin to remove any pulp or particulate out of the way. We'll take 25 mils from that solution, and we will add that to a conical tube, and now we're going to do a fast spin. We're going to spin it just under, I should say, 4,500 Gs, and that's going to help us pellet any of those Alicyclobacillus cells that are present. From there, we're going to resuspend with a buffer. So we resuspend at 500 microliters of buffer, and we transfer to a lysis tube. The lysis tube is a very nice bioMérieux innovation. It's a self-contained system without a cap. We really like it when we do our development here because it is a very simple 5-minute mechanical lysis. So we transfer to that tube, shakes for 5 minutes, and now we transfer to PCR. So you can get through that methodology pretty quick. If you've got a clarified juice or a juice without pulp, you can actually skip that first initial centrifugation. So now you're enriching, transferring to a tube, let's say with a clarified product, and doing your fast spin first, right? Then going to a 5-minute lysis and into the system. After about 2 hours of cycling, we have our results. And again, for each test, we have 3 results, as I discussed. So pretty nice streamlined methodology. Internally, through our network globally at bioMérieux, we've been able to get we've been able to, as I said, assemble that library of strains. So we've got multiple different strains of Acidocaldarius and Acidoterrestris from all over the world, isolated from contamination events all over the world as well. And as we like to say, you've got your 3 targets. We've got, does it produce Guaiacol or not? And then we determine, is it ACB Pro? Is it obviously Alicyclobacillus species? And the way we're determining Guaiacol production, as I mentioned, is through that benchmark peroxidase test to determine does it produce Guaiacol or not. We've looked at multiple species. So Acidoterrestris, the rule continues to hold here, but we have seen instances where we don't see Guaiacol production on that species, but typically, as Emilia touched on, we typically see Acidoterrestris being a Guaiacol producer, with Acidocaldarius also being somewhat common in the environment, not producing Guaiacol. We've had an opportunity, as I mentioned, to look at multiple other species of Alicyclobacillus. One that was new to me in this project was the, and I'm looking here on the bottom right, was the Alicyclobacillus cacagoensis. And I'm a stickler on proper pronunciation, and I hope as this one was new to me that I am pronouncing it right as well out there. But it's been a pretty exciting project to get hold of multiple different species of ACB. Some came to us from our colleagues in Europe, some from Japan, and we've been pretty excited about it. But I think what's most important is the rule continues to hold fast. That set of genes that we target, should they be present, at this point now, we have always seen those genes present, Guaiacol production is happening, right? Those genes are not present, no Guaiacol production, right? So thus far in the marketplace, it's been, the rule has been holding fast, and the genes that we selected and our team obviously elucidated during their exercise seem to really be adding value to our clients out there and being able to do it obviously in about 27 hours, which is exciting. When we look at things, and I won't touch too much on it, but certainly we can provide this type of data. When we're building an assay, certainly we want to look at false positive rates. So we want to make sure other things out there with regards to exclusivity are not going to cross-react with our assay. The only species I always like to touch on when it comes to ACB is the Bacillus amyloliquefactions. This tends to culturally look a lot like ACB. We've seen it isolated as well, but as you know, it is not a Guaiacol producer. It is not ACB, but we always make sure that given the look and feel of this, that we don't hit. There are multiple other species that we've looked at with regards to exclusivity, and at this point, we haven't seen anything that cross-reacts with the assay in the market that we've isolated or seen in the marketplace. Other things, though, that I think are most important is, we had an opportunity to work closely with Cornell University, and they've got a remarkable team out there, and they've been great in terms of their ability to help validate these types of assays, and also to help us understand some of the genes that we may be looking at to determine what might be the right target with regards to a new PCR assay. And I want to share some data that's coming out of Cornell, and this is out of Abby Snyder's laboratory at Cornell. She did a study where they looked at with the new ACB Pro, with the new Pro ACB assay, where they looked at multiple juices. They compared this all to IFU enumeration method. So remember, there's the enumeration and there's the enrichment methodology. They are both different from one another. And what we looked at here was spiking individual samples with a high inoculation, with a medium inoculation of cells, and with a low inoculation. And this is CFU per 10 mils, which obviously is equivalent to what the IFU would be looking at as well, 10 mils of juice. So we have our cell counts here on the left, first looking at apple juice. We were excited to hear about this data. This data will be published shortly as well, along with additional data coming out of Cornell that Abby's team is putting together. This was some of the initial data in comparison directly to IFU. We had very good alignment, certainly with the qualitative method, but interestingly, looking at the enumeration method, we find that we are outperforming the IFU enumeration method with regards to sensitivity. What I think is exciting is that when we see the ACB, let's say something like Acidoterrestris, or another species, we're seeing very good alignment with even low levels of those spikes, and the gene presence for Guaiacol is there, and the gold standard benchmark assay for the peroxidase assay obviously is lining up very well with our detection. So again, looking at both juice, and the other point that I want to mention here is this is holding true across spores as well, right? So the actual spores themselves too. Things like orange juice as well, coconut water, syrup solution, and water. These were all things that the group at Cornell University also looked at. And again, looking at those nice low levels of ACB, we're showing that we're able to get good recovery of the bug, right? We're able to line up. And I think what was most interesting when Abby had shared this data at the IFP conference earlier this year was the outperformance of the IFU enumeration method. This is a method that is, we do our dilution up front, and we are then combining that solution with a molten agar and going onto a plate. And I think it was pretty interesting to see the outperformance of it by our methodology. But again, you really have to go to that qualitative method, which is a longer process. And that's where we start to see a much better equivalency here. The other thing then, we say next steps, how can we continue to push the boundaries of the assay? So we still have several groups out there who are very interested in the level of Alicyclobacillus that's there. So we worked with a group in Europe over the past several months, and they validated on their end, and we obviously with our guidance, they were able to validate threshold enumeration of the assay. So we were able to determine levels of ACB that are present. And from there, then we can give some additional data to say, not only do we have Guaiacol production or not, do we have, is it ACB or not, but we can give you a range or a level of ACB that's present in the sample now also based on the CP value that we're seeing. So at this point, next steps for us is, now that we can understand whether it's going to spoil or not, and we have that data, I think it would be exciting for our clients we work with to overlay some of the metadata, right? When do we see ACB bloom or not? Is it seasonal or not? Is it based on specific raw materials or not? And having this type of data really helps us to answer, I think, some of these questions. As I always say, not all spoilage is created equal, and this helps us to answer that question as to whether we're going to have a spoilage event or not. That said, in summary, we had 100% correlation at this point between whether that set of genes is there and Guaiacol production. There's superior specificity of the assay with regards to ACB. There is not a need, in our opinion, to reflex to the enzymatic test, 27 hours, and we're done. We know ACB or not, and we know whether it's going to spoil or not. equivalence in performance, as I mentioned, to IFU, and very simple in terms of the workflow. We've had a lot of good compliments on it from our groups who do the workflow quite a bit. It is very easy. I've run it myself multiple times. And then the other thing that I like to say is, as we understand more about spoilage and we understand things like heat resistant mold, for instance, we want to apply the strategies we've developed here to continue to build assays that are going to be more predictive of spoilage. We'll certainly, I think, at this point, open it up to questions, and I appreciate everyone taking the time to join on today.
So thank you, Benjamin. It's time for the question and answer session. So there is a lot of questions on the, so let's take one. So I think it will be for you, Emilia. There is one attendee who is asking which one of the stages of the juice processing is more important to prevent ACB spoilage.
Well, as I said, the most important would be the steps where soil contamination occurs. So if you are using a juice concentrate, it will be from the moment the fruit is harvested, washed, and processed. So, like I said, a lot of people concentrate on the production of the final product, but they should be concentrating before that.
Yeah, very important to test also for the raw materials. That's clear that the entrance of the contamination in the factory, that's for sure.
Yeah. Yes.
We have another question still for Emilia. I think it's should I always identify the ACB species causing the spoilage?
Certainly. I mean, that's one thing that I always tell people. You need to identify what is spoiling your product. Just saying that, oh, we have Alicyclobacillus, that is not enough. You have to identify it because, as Ben said, they may or may not be Guaiacol producers. So yeah, that is always very important.
Thank you, Emilia. There is, let me see, still another question about processing or environment. Should processor implement a process environment sampling program, environmental program?
That's one thing, yeah, that I don't think people do enough. I mean, people are concentrating on ingredients, but many times they concentrate on the final product, and that's not the way to do it. Once it is in the final product, game over for many cases, depending on the formulation. So yeah, like we do for heat resistant molds, people should know what they have in the environment, processing environment. They should know what the water, the processed water looks like. So there are many sampling sources that they should still use. And we still don't know what is the effect of the presence of these spores in the processing environment, because like for HRM, we have done a lot of testing and assessment of many plants, beverage plants, but for Alicyclobacillus, we have not yet.
Thank you. Another question is coming. It's also linked to the spores. Someone is asking, will the presence of ACB spores in the processing environment give a high spoilage rate? Is there a link between the presence of spores at high level on the effect in terms of spoilage?
Yeah, and then again, we don't have a lot of data, but as in the case of HRM, usually it gives a small percentage, even though we have seen higher, like 1 in 10,000 bottles. But usually it's going to give you a little bit of a spoilage. So the only problem with that is that you will never have a spoilage-free product. Yeah.
So, yeah, a lot of questions for you, Emilia. You have a lot of success today. Someone is asking, what is the growth curve for these spoilage organism at different storage temperatures?
What is the, can you repeat the beginning?
Yes, what is the growth curve for these spoilage organism at different storage temperatures? I think that the person wants to know about the link between temperatures of storage and the capability of growth of these ACB.
Yeah, so, you know, if you store your product below 20 degrees, it's the standard, because we know that none of the species that we have found so far can grow below 20. So if you store them at below 20, then the chances of growth are very, very low. While if you store them at 35, 40, let's say in summer, you know, when you have a warehouse that is hot, then the rate will be a lot faster. The growth rate also depends on the formulation, you know, fruit juices, mixes, beverages will allow it to grow faster or slower. But give it a higher temperature, higher rate of spoilage, certainly.
Thank you. So I think the next question will be for Ben.
I get one. All right.
There's a question. Yeah, for sure. That will be the first one, not the last one, I think. Then can the test be used also for processed water?
Yes. Yes, it can. And the team at Cornell had done that work against different water types. So it certainly can be.
And same, it can be used also for sweeteners, all the ingredients that are adding to the juices, right?
Yeah, that will be, a lot of that will be that data in the paper that is coming out later on this year. But also on our end, we certainly can share that data. Sweetener solutions were very much part of our internal development process, given obviously the history associated with ACB contamination and spores in sweetener solutions.
So let me check.
Yeah, we have another one, probably for Emilia. Can the growth temperature be used to identify Guaiacol positive from Guaiacol negative, or at least to inhibit one of the two?
Can the growth identify that? I don't think so. I mean, you do have species that will grow very well, but you certainly will not know until you run the test, or if you put the species, you know, through Ben's machine, and then you know for sure. But yeah, I mean, the type of growth will not determine. The one thing you can do if you want to do something fast and you don't want to use the methods for Guaiacol is to heat shock the spores and then inoculate an apple juice. And then you incubate it and you will know. Or that's what Dr. Jensen proposed.
Okay. Thank you.
Another question, it's more about spore resistance to treatment. What is the ACB spores resistance to peracetic acid as a sanitation ingredient? So can the peracetic acid can damage the ACB spores, avoiding the growth?
I couldn't. For some reason, I cannot hear your. Yes, like chopped.
The question. Yeah, the question is, what is the ACB spores resistance to peracetic acid as a sanitation ingredient?
Well, there are some studies, a little bit conflicting results. Some people say that it doesn't inhibit them. Some other results will say that a high concentration it does. And peracetic acid is good for biofilm removal. So, but the concentration will have to be higher. So that, you know, but yeah, it's very conflicting when you read about these publications, you know, the way they do it maybe. And it's, yeah, I mean, I think chlorine dioxide is still better than peracetic acid, but at the right concentration, it may still be working.
Yeah, which is quite logical. Yeah. There is a question, although it's more about the percentage of fruit juices in beverages. The question, Emilia, is please, do you have any data or information on minimal percentage of fruit juices in beverages that can lead to ACB goals? So it's more a question of formulation of juices.
I am not sure that ACBs require juice because they do grow on herbal teas, they grow on sport drinks that certainly do not have any juices. So there is not, I don't think it's a requirement of a percentage of juice in the product. It's not like lactic acid bacteria that they certainly need the nutrition that the juice provides. In this case, they do not. So, you know, they can grow at 100% juice, at 10% juice, or no juice. So the only thing will be the precursors for the Guaiacol formation. Are they present or are they not? So some formulations, like with the sport drinks, maybe not all of them will spoil. There are some formulations that have more precursors, more vanillin, and then they will spoil.
Thank you. Here, it's a question for Ben. Ben, if we don't do any pre-incubation with GeneUP, what is the minimum concentration that GeneUP can detect without enrichment? So I think it's more a question about quantification with GeneUP.
So the enumeration at the end, I mentioned additional things that we did, and that one of them is the threshold enumeration. And again, it was a partner in Europe who did the work for us there against that. But the minimum level, so that obviously you wouldn't enrich. Obviously, if you enrich, you're not going to be able to quantify, you know, what level of bug is there. So it's for groups who want to. I look at the threshold enumeration, and it's typically, okay, you know, we've gotten a positive for ACB. It might not be Guaiacol producing, but I want to understand still what level of ACB that I have there. So I'm going to go back to that original sample and run from it, right? Not to the enriched sample, right? But to the original retained sample. And your LOD then is about 10 cells per mil is what you're looking at without enrichment. And that's why we're able to give that range. But anything less than 10 cells per mil, you know, we're probably not going to be able to detect it without some level of enrichment.
So thank you, Ben. There is it will be probably the last question. If we have not answered yet to your question, no worries. We will answer to you individually. There is a lot of questions still pending, but we will send you the answer. So the last question will be for Ben. That's the minimal 24 hours incubation guarantee the detection. Because Mrs. Rico said Alicyclobacillus is hard to grow.
Well, I'm sorry, Sebastian. What was the question? Is 24 hours the minimum?
Yes. Is it enough to detect?
Yes. Again, everything that we did here was demonstrating equivalency to the, again, importantly, the IFU enumeration method. Same with our outside partners when they've done their validations, we demonstrate equivalency. And as I show in the data, or at least as Cornell independently showed, Our methodology actually outperforms with regards to sensitivity, the IFU enumeration method, but we're doing that with a 24-hour enrichment. So I wouldn't recommend that you have to enrich any longer. You know, we're equivalent at this point, and as the data suggests, we're actually have a higher degree of sensitivity than even IFU enumeration, and that is with a 24-hour enrichment.
Yeah, we have this data from Cornell supporting, and also we have some data also from other studies which have been now be conducted on site in factories. So it's clear that 24 hours it's working.
Yeah.
So thank you. So now it's time to end this webinar. So on behalf of bioMérieux, I would like to thank you very much, Emilia and Benjamin, for their time today to share this information and their knowledge about ACB, about the detection of ACB, about the importance of moving to molecular solution to be at front of the problem in the factories. Just last information, so we are very pleased to announce that it's just a start on this webinar, and we are going to continue to speak about spoilers in the beverages industry. We are going to organize a conference, and it will be next year in March. We have already the date. You can note in your agenda that on March the 22nd next year in Vienna, we are organizing the European Beverages Quality Conference. Emilia will be there. I think that Ben might be there also. And it will be in combination with the workshop organized by the IFU organization. And again, topic will be about spoilers, ACB, but some others. And so you will receive soon some more detailed information about this conference. But you are more than welcome to join this conference in Vienna next year in March. So again, thank you very much, everyone, to be part of this webinar for Alicyclobacillus. I wish you a very nice day wherever you are in the world, because we had people from everywhere in the world, from Asia, from Europe, from Pacific, from US, from really, it's really amazing. I am very happy of that. So thank you again, and wishing you a very nice day. Thank you very much, and goodbye.
Thank you.
Thank you.
Thank you.
Bye. Thank you.